She said, "Oh wow, are all your conferences this fun?" I'm like, "No, not really." So it's true. I really like this conference. There's a lot of really interesting technical talks that I enjoy learning from. It's not always true. You know, a lot of times I go to database conferences and I do databases all my life, so it's like I don't learn a whole lot. But when I come to Self, obviously there's a whole plethora of stuff that I get to learn. And I was looking through the book, and there's a lot of great stuff. So I am looking forward to that. Uh, but today we're here to talk about Postgres, specifically to talk about Postgres and security, and specifically talk about Postgres and security from external attack. And I'm going to go into details about that. Just an introduction, my name is Bruce Momjian. I am one of the Postgres core team members. I have been working with Postgres since 1996. And I work for a company called Enterprise DB. I've been with them for 9 years. And they provide basically, enterprise support and tooling for Postgres. So it's a kind of a good mix. I get to travel a lot, like this conference, and they help the community out. The community helps them out. It's a really great thing. So this talk actually is sort of a little derivative of a talk from another core team member called Magnus Hagender. He actually gave a security talk like maybe 5-6 years ago, and I was like, that's a good talk, but I couldn't graphically understand it. I had to really kind of work. So I said, all right, let me take this angle and really sort of give it a visual approach, and I think you're going to see that from this talk. So what we're really going to talk about are the attack vectors for a database. Now, this is not technically only about Postgres. It's certainly true of pretty much all the enterprise databases. They're going to have little different answers to some of these problems, but the types of problems that you're going to have are going to be the same, because of course a database is where all the data is. That's where everyone wants to steal from. I was on the plane yesterday coming from Philadelphia, and there was an article about the fact that all of the federal employee records seem to have moved to China, just magically for some reason. Very disappointing, I'm sure. So again, your database is sort of the crown jewels in a lot of cases. This is one of the reasons why databases are so sticky within organizations, why reliability is such a requirement. People sort of say, well, why don't you do this with Postgres, or why don't you release every 2 weeks, or why do you have so much, such a long beta period? I'm like, well, I said, if your browser crashes, you just start the browser. If your database crashes, that's not so good. It may not start up again, and people don't like their databases crashing. So again, there's a different sort of an expectation for a database, and I think there's a different sort of expectation for security in a database. And what I'm going to talk about today is to try and sort of visually give you an idea of what those attack vectors are, what they look like, and some of the solutions that Postgres has. And by transitive, some of the other enterprise databases have very similar solutions in this area. Although I have to admit I don't know the details about almost any of them, but I'm sure some of you in the audience do. So what are we going to talk about? I'm sorry that the title's kind of chopped off there. We're going to talk about external attack vectors. So, oh, thank you. So we're going to be talking about the idea of attacks coming from outside of your database by people who have no permission in your database at all. Okay, this would typically be things like password attacks, network sort of attacks on your database. Certainly much more significant when you're talking about having a database which is open to the internet, right? I mean, it sounds kind of like years ago that would sound kind of crazy, but that's pretty much the default for Postgres now. That a lot of people have databases that are just open to the internet. A lot of organizations don't do that, but again, there are some, and there are some reasons that happens. And of course, Postgres being sort of an internet developed project, we would certainly want to have sufficient security so that people who had databases open to the internet would be able to use those effectively, and we'll talk about how that happens. We'll also talk about some other sort of more administrative related things, things like backups, server theft, and administrative access, and what that means. What we're not going to be talking about are things that are internal. I could have a separate talk about this, but that's not this talk. So things like database object permissions, the grant command, SQL injection attacks, application vulnerabilities, operating system compromise. These are not things we're going to cover in this talk. Again, it could be a separate talk. I'd be glad to answer questions at the end about it. But again, I don't have any slides particularly to this. Also, I have an hour, so I got lots of time. If people have questions, feel free to ask. If I can't answer them, hopefully somebody else in the room will. And you know, I enjoy getting questions while I'm talking because it makes it more interesting. You don't have to hear me talking the whole time, and usually whatever you're thinking about, somebody else is thinking about. So, any questions so far? Okay, yeah, usually I don't get any questions at that point. Okay, so let's talk about authentication security. Big, you know, the old style vaults there. So Postgres has a file that effectively controls network access to the database. This is not like an SQL command file. This is actually a physical file that is processed before the person even can connect in on a socket. So if you're familiar with TCP/IP, you have the bind and the, what is it, connect and bind. And then before we're going to take that connection, we're going to run it through a filter, okay? Before we actually start allowing them to issue SQL, before we kind of get into any kind of activity, we're going to run it through a filter. And this filter effectively is the Postgres comp file. Now, one problem right away is that because Postgres is effectively designed for like to be sort of installed on a developer's machine, we're going to lock that down. So we're going to basically say in this file that no one can connect into this machine except from the local machine. So we're basically saying by default when Postgres is shipped at the source code level, not necessarily RPMs, but the source code level, you can't connect from outside to that machine. Okay, that's the good news security-wise. The bad news security-wise is that you've got this trust thing over here on the right-hand column, and that trust thing is basically saying that anyone from the current machine can connect into that database as anyone else. That sounds kind of bad, and it works well for a developed machine. It doesn't work well for almost any other setup, okay? Now, as I alluded to earlier, a lot of installers will actually change that install method. And if you notice the bottom there comment, there's actually a way when you initialize Postgres to change that trust to something else, okay? And normally our installers are going to use a capability called peer. If you've ever heard of peer, it's basically a way that the one process can ask the operating system who is on the other end of that socket. Because again, remember when you're on a Unix machine, if you're doing Unix domain sockets, those sockets exist in the temp directory, for example. One person connects and then the other person's listening. So it's like a little pass-through thing, right? So you can actually, the server can actually ask the operating system on BSD and Linux and I think Solaris, and I don't remember any Unix operating systems that don't support some way of listening on the other end and saying, by the way, I'm listening on a socket here. Can you tell me the username who logged in on the other end of that socket? That's effectively what it's doing. It's saying, and this is a fairly common capability of Unix. It goes into the kernel. The kernel kind of looks up and says, "Oh, I see. That's that process that's sending data to that Unix domain socket. I'm going to give you that username." Great way of authenticating. User can connect to the database. They don't require a password because again, they've already authenticated in the operating system. But it doesn't allow them to become whoever they want to be, which is effectively what trust does. Okay, so there's the good and the bad of sort of Unix domain local connection kind of capability. Okay, now there's a lot more to this that I'm kind of not showing you, and I'd be glad to show you, assuming we have time at the end. There's only 3 lines in this file. The first line is Unix domain socket. All the rest are comments, right? So Unix domain socket, this is TCP/IP, and this one is IPv6 TCP/IP. Okay. This I've only shown you 3 lines. There's a whole bunch of stuff you can do that I'm not even showing you. Okay. So you can actually set up very complicated hierarchies where you say only SSL can connect, and there's a whole bunch of. Let me show you real fast, because I think I do have time, and because I am blessed with having internet, which fortunately no one has slowed down for me, I can actually pull up. We're going to go off script here, because that's the kind of person I am. Okay, here's the slide. So there's the InitDB. Where is it? Where are you? Yoo-hoo. Okay, so this is a standard Postgres conf, and this is the example I wanted to show. So let me full screen that. Is that full screen? I guess that is all we get. All right, so hopefully you can read this. I know it's a little bit on the small side, but oh, you know what I could do? I can zoom in, can't I? Oh wow! It pays to use Firefox there, because I know the keyboards that work. So this is a little better example, and I don't know why I didn't have my slides. So what you're seeing here are, I'm going to look at 2 examples here. This first example allows you to, suppose you have a network where you have a network and you want everybody in a specific network to connect to your machine, but you have a gateway machine in that network. And that gateway machine is the machine that connects, obviously, outside. And you never want that gateway machine to connect to the database. There's no reason for it to connect to the database. I'm a little more suspicious of that server because it is connecting outside. So what I can actually do with this Postgres conf file is I can say, I want to allow everybody from this specific network to connect to my server with a password, but I will not allow that particular gateway machine to connect. So what happens when you read the file is the first line matches. So in this case, for this 254 particular host, it's saying, okay, if you match that IP address, I'm going to reject you. And then over here, I'm actually going to allow anybody else in that network. So you can kind of carve out things. Similar down here, and I'm going to get into some more detail later, but what I'm saying is that I'm going to open this database to the entire internet. All right. And I'm going to allow, but I'm not going to allow Postgres to connect. So you can't connect from the internet as the super user, okay? And I'm also only going to allow SSL connections from the internet. I'm not going to allow normal connections, just SSL connections, and then they're going to have to supply a password. Yes, sir. When they're rejected, you can actually, I'm trying to remember, do we log? I think we do. I know we have logging to control what gets like reported. I think it does log that, but I don't remember for sure. I should know that, but it's been a while. It does. Okay, I think it would say rejected from, yeah. Good. 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 But my point is you can kind of layer stuff on top of each other in an interesting way. Yes, sir. So performance pen, the question is performance penalty for SSL. SSL's biggest performance overhead is not actually the on the wire part, it's the startup. So what we typically do, if we have somebody who's doing a lot of very short connections, then sometimes we'll tell people to use like a connection pooler. But then the problem is that what if they aren't using SSL to the connection pooler? Like, so we could get SSL from the connection pooler to the server, but then what about getting the connection pooler? I have a blog entry that actually measures the SSL overhead, and it's again mostly on startup, but it's definitely there. Oh yeah, absolutely. So anyway, just went off script for that one, but I just wanted to talk a little bit about that HBA file. And here we go. And somebody said we do this and we do that. Yay. Oops. How did we full screen that? Maybe that. There we go. Okay. Okay. So we got the SSL, we got the connection set up. Okay. However, the first problem, and again, let's just look at this file. So this file is not mentioning SSL at all. Okay. And here we have a case where we've now connected to the database, but maybe we've given them a password, but the problem is that the password can be seen, okay, because you're effectively sort of sending whatever you want over the network, okay. So the first problem is that in an open system, we have a password that we probably want to, make invisible. So the way we do this is we have a special authentication method when we're sending a password called MD5, okay? And I know everyone's like, oh, MD5, it's an old hash, whatever. The way we're using it, it's not a security issue. We've been over that a bazillion times. Effectively, what happens when you connect with MD5 is when you say, I want to connect, and the server says, I want a password, it sends a random number, what we call salt, to the client. And what the client does is it takes its original password, the password that it was typed in, it takes the username and adds to that, hashes it. Then it takes the salt and adds that and hashes it again, and it sends it back to the server. So you might be wondering, well, why would we have this random salt? Why is it being sent by the server? And it's really to prevent this problem, so that effectively that password packet that gets sent across to the server is only really valid for the salt that was supplied by the server. So because each connection gets a new random salt, you effectively are preventing any kind of replay. You've already MD5 hashed it, so the person can't see the password, but they also can't replay the password because the password has been encrypted with this random salt that can't be replayed unless you happen to get the same random number of previous sessions. You'd have to start saving lots of sessions, right? And then try and catch a packet and try and, So you kind of get the idea. So that's how we encrypt the password when it's sent across. That's why there's an encryption method called MD5, because effectively it's sort of randomizing and preventing replay of those particular packets. Okay. Question. Okay. Now, there's some other password attacks that are kind of serious. Weak passwords, reuse of old passwords, brute force password attacks. Unfortunately, none of these are really addressed by Postgres. Usually, if somebody is concerned about these things, we're going to recommend something like LDAP, PAM, SSPI, which is really designed to manage passwords, right? It's designed to have all of that infrastructure as part of it, and we're going to recommend that people use that for authentication. Postgres actually supports, I think, 11 types of authentication. I can barely remember them all, but I think they're like, Radius and what's the other one? Yeah, the peer and the MD5 and the password and the GSS Kerberos, and there's another one called. There was one where you used to have a daemon that would sit up. You would run it inetd, if you ever used that. So again, we have a whole bunch of authentication methods that are supported. Nobody seems to have a problem missing any of those. Or like, okay, like one of them is going to match. And again, we kind of, it's a pain to carry them all, but if you're going to deploy Postgres, you want it to work with whatever authentication you have, and we got to match that, so we do. But that's not the end of the job, because obviously password security is just one part of it. Once you've gotten the password across and you've authenticated yourself, what about all the queries and data that go back and forth? Aren't they important? Aren't they things that you would want to secure, right? Because of course your select's going to go across. Give me all the employees who make over, $30,000, and then the answer is going to come back, right? And all that data is effectively going to come back across that network. Okay, so the first thing people are going to say is, okay, I'm going to use SSL, right? That's sort of the go-to way of securing your network. And all of a sudden, when your data gets across, it doesn't get sent across directly. It uses actually a symmetric cipher called AES-256 to basically send the data across, and the data comes back in the same encrypted way. In fact, SSL only really uses that sort of public key, private key thing for the key exchange. The rest of the stuff is just symmetric key. So you aren't actually doing that super complicated. That's why the startup is so slow, because it's doing this the very slow, designed to be very slow, public private key stuff to get started, to exchange private keys between the two servers. But once it's done, exchange public keys. But once it's done, then it effectively just uses symmetric key, and then it renegotiates every 500 megs or something like that. So you think, okay, I've got my password encrypted. I'm using MD5, and frankly, if you're using SSL, you don't even need to worry about it, because now the whole exchange is encrypted, right? You think, okay, my job's done. My job's done except for this person, and this is a term. There's kind of two terms that I've kind of thrown out here. One is snooping, which effectively means I'm going to watch the data that goes across the network. And of course, we're here at a conference, so you could probably do the same thing. If you put your laptop or your device in promiscuous mode, you can see the packets going across. That's snooping. The second thing is spoofing. And they sound kind of the same, but they really aren't. It's like authentication and authorization. They sound kind of the same, but they aren't. So the problem with this person is that they're not reading data as it comes across. They're pretending to be someone that they aren't. And that's where sort of the problem comes in. So here's a first case, which I think is really sort of an odd case, but it's interesting. And we do document this limitation, partially because I'm one of the people who does a lot of the doc stuff. And I'm like, we should tell people about this problem. This is kind of the most simplest case of spoofing you could do. The case is that you have this, the database server is down. Database server is down for maintenance for some whatever reason. Okay, maybe you're upgrading, maybe you just, I don't know, whatever. The database server is down. Postgres listens on a non-privileged port. In fact, the default is 5432. But in fact, I don't think you can even run Postgres on a privileged port, because you can't run Postgres as root. So by definition, you're going to be running on a non-privileged port. TCP/IP ports above like 124 are non-privileged. Yes, sir. Oh, so okay. So the question is, there is a way to run Postgres on a privileged port, but you'd have to you might be able to configure Linux to allow that. That does make sense. You would give sort of the Postgres user the right to run on a specific port that was restricted normally to just root users. That would make kind of sense. Again, you have it running on a non-restricted port. Again, that's usually 124 and up. But because it's down, and it's because it's a non-privileged port, someone else can run on that port, right? There's nothing saying you can't. And I'm sure a lot of the databases have the same vulnerability, okay? So effectively, your server's down. Somebody just starts up a database server that looks like a Postgres server, and all it does is to reject connections. So it doesn't have to do anything. It just has to say, oh, listen on 5432. Connection comes in. Hi, can you send me your password? And they send it back, and it's like, oh, here's your password. And you're like, okay, just disconnect. Bye, right? And you just do that over and over again, and you collect a whole lot of passwords. Now, kind of with the MD5 thing, you kind of don't really get a password. You just get this blob that you can't really find the password for. But the server really controls what the client sends. So you could just say, no, don't give me them, just give me a plain password. And the client's like, okay, that's what you want. I'm going to send it, right? Not a good thing. But you kind of get the idea that somebody running on a malicious, again, as I'm saying at the bottom, the server controls the choice of authentication. And because it's saying, I will connect with password, the client will happily send a password across the clear, and then just connects. And then once the server starts up again, it can then use the password to connect and do whatever it wants to do. So that's just kind of an odd spoofing, but I think it's important, and we do actually mention the Postgres docs, which are probably 3,100 pages and counting, very extensive. So fine, the server just sends the plain password, completely unrestricted, and it saves it for later. Okay, so you might think, oh well, what if my server's up? Am I okay? Okay, and the answer is you're not. Here's another case. I'm going to see if I can get a little clear here, where what the spoofer has done here is they've actually created a fake server between the user and the real server. And you might think, oh, this is impossible, but effectively, if you know, in fact, I saw on the instructions there's a routing talk that somebody's giving, I think tomorrow, and maybe we wanted to watch that, because effectively it is possible to kind of fake an IP address. That's why we use SSL certificates, because when we go to a website, we aren't really sure it is who it is, except that we have the SSL certificates. I want to get into that in a minute. But my point is that it is possible to pretend to be some other IP address, or some other DNS name or whatever. So effectively what happens is the client connects to the fake server. The fake server can actually be invisible. It just passes the same request onto the real server. It gets a reply, comes back. It obviously picks up the password as it gets sent back. Oh, let me remember that password. And then the client starts sending queries, and it just passes them through back and forth. So the client really doesn't know. Unlike this case where we're actually disconnecting, the client has no idea that there's somebody intercepting traffic. Of course, they can modify the queries as they go across. They can add new queries that weren't there before. All sorts of bad things can happen here. And that's just really kind of nasty, I think. So people are like, okay, well, how do I improve that? And the first thing is, I'll just use SSL, right? SSL is going to be like my magic sauce, which is going to fix whatever security problem I have. That's only partially true. So client says, you can actually tell the client, I prefer SSL. And in fact, that's the default authentication method. So you say, okay, I'm gonna prefer SSL from the real server. And the real server the fake server, it thinks it's the real server, the fake server comes back and says, I don't support SSL. Okay? And then the client's like, okay, if you don't support SSL, I'll just go non-SSL, and everything just continues, and we get our same problem as before. Okay? So then you can actually have there's a setting at the client level, at the libpq level, at the JDBC level, where you say, I'm going to require SSL. Clearly, this must solve the problem. Okay, but in fact, what happens is the client says, I require SSL, and I am not going to talk to you unless you will do SSL. And the fake server says, sure, we'll do SSL. And it sends back a certificate and says, this is my SSL certificate. Let's talk privately. And you're like, oh, yeah, okay, good. Oh, here's my query. Here's my password. And the whole time, the fake server is actually talking to the real server and then passing everything back and forth. Okay? So my point here is that just because the client has said, I want SSL, doesn't mean we're actually secure, because the fake server could do SSL just as well as a real server. Okay? So what is missing? Well, obviously, this is not the way SSL is designed to work. This is, unfortunately, this is the way a lot of people configure SSL in database environments, okay? But this is definitely not the way it should work. The only way you actually can use SSL to prevent this kind of spoofing is with certificates. And I know that's sort of this ugly thing that sounds like a lot of headache, and in some ways it is, but the only way we can actually prevent this kind of spoofing is with a certificate. Because what the certificate does is it tells us when we actually set our client to say, not only do I want to use SSL, but I will only talk to another server that has a certificate that is signed by the same certificate authority as my own certificate. That's effectively what that web of trust does. Okay, so the client has a certificate that was issued by a certificate authority, either through a private certificate authority or a public certificate authority, and the server has a certificate that was assigned by the certificate authority. And it's easily to identify when the client receives the certificate back from the fake server. It can very easily identify that certificate is not signed by the same certificate authority. Therefore, it is not actually a certificate that I'm going to value, and I'm going to reject it because the certificate is not valid. Okay. There's a whole lot of documentation in Postgres that explains how to create your own certificates or your own certificate authority that you can then sign additional certificates for individual servers and clients. Okay. And that's how the clients and servers know who to trust. You probably have also heard of public certificate authorities, things like VeriSign, Rapid SSL I happen to use, Equa something. There's a whole bunch of certificate authorities out there. And the public certificate authorities are typically out there to deal with websites. Okay, so I go to the PNC website, and my browser has a list of certificates that it trusts, and PNC has obtained a certificate from a certificate authority like VeriSign. Give me another name of your certificate authority. I'm falling blank here. I'm sorry? Galt? Okay. Another one? Well, anyway, there's a whole bunch of them. So PNC has obtained a certificate from a certificate authority. If the certificate issuers in my browser, okay, match the signer of the certificates for the PNC bank, then that website is considered to be authenticated, and I get that little bar at the top that says this is actually PNC Bank or Wells Fargo or Chase Manhattan, whatever. Okay, and that's how I know when I go to eBay or I go to Amazon, I know I'm really talking to Amazon. I'm not talking to somebody else. Okay, because the certificate, when I made that SSL connection to the website, is returning a certificate, and I can actually cryptographically check that its parent, as I read the certificate chain, because usually the certificate's going to have maybe a chain that goes up, cryptographically signed all the way up to the issuer, and it's going to match something in my browser. Okay. However, when you're doing a database, it's a completely different environment. You're not going to be connecting to random Postgres servers all over the internet. I don't think you're going to ever do that. Okay. So in a lot of cases, it's actually better for organizations to create their own private certificate authority. Because frankly, if I'm creating a database, I don't want VeriSign to have a key to go into my database, right? I mean, effectively, I don't want them to be able to create a certificate that could be used. I want to be able to create this certificate that can control my environment, okay? So usually in a database environment, because you're not connecting from unrelated sites, hopefully, you're probably going to create your own certificate authority, and then you're going to issue certificates, one to each server and then one to each client, and that's going to be your web of trust, and that's going to prevent the spoofer from getting in and effectively spoofing or pretending to be a server that they aren't. Now, you might have a case where a fake server actually gets a certificate from another client. Like somehow there's some breach of a client somewhere, and that fake server gets a copy of her certificate, not the certificate for the server, but a certificate for one of the fake clients that's out there. Okay, one of the let's suppose I've got, like terminals, and somebody steals one of the certificates from that terminal. Should that certificate be allowed to represent a server? There's another mode, which is usually the one we recommend for Postgres, called verify full. And what that tells the SSL, it says, not only do I want a certificate that's signed by my same certificate authority, but I also want the host name in the certificate, the common name in the certificate, to be the same as the host I'm trying to connect to. So if they steal the certificate from client 112.pnc.com, and they put a certificate there, client 112.pnc.com, they put it there and they say, I'm the server. Like, no. The name of my server is not client 112.pnc.com. The name of my server is, huge amounts of money at PNC, whatever. Okay. So it basically forces the certificate to even be a specific certificate that matches that particular host name. And that's how you lock down Postgres, and that's how you lock down SSL in pretty much any environment. The cryptographic part of SSL is nice, but it's not really thorough. And in fact, if you've ever used SSH, which really doesn't have this certificate authority design, do you know how they do that? Effectively, when you connect the first time with SSH, what do you see? You see, do you want to trust this MAC address or whatever, this key sign? And you're like, well, I think so. I mean, it's really embarrassing. I think so, right? And then if you SSH 3 months from now, you might get, it'll work fine for 3 months. Then 3 months you SSH in, and you say, what is it? Fingerprints don't match. Usually like a message. And you're like, well, if I go ahead, then my password's going to be sent to this thing, right? Because you're going to still be using a password in SSH. Or no, I'm sorry, your certificate's going to be sent. So it's not like super terrible. But then you might be on a machine that isn't really the machine you want. So then you got to call the admin. You got to say, hey, I'm getting this error. I was SSHing in for 3 months, and now I'm getting this message. And he's like, well, we had a problem. We had to reinstall, and we lost the certificate. Right? They're like, okay, yes, I trust you again. I mean, really crazy. And it really doesn't work very well. But that's all we have for SSH. At least that I know. I don't know of any sort of overall certificate authority for SSH. SSL at least does have this kind of capability. And I'm sure there is a way to do it in SSH, but has anyone ever actually done it? People just say yes, and then they trust it, and if it changes, then they go berserk. So this gentleman's saying he's never gotten a call saying, and you've changed the certs and nobody ever calls you. Yeah, that's concerning. Yes, that is concerning. I have called people, and they have, or at least email them and say, hey, something's wrong here. And I usually get, but also I rarely get an email that says, by the way, our certificate has changed, be prepared for a new. So, at least you're kind of prepared, because you're right. I think I'm probably the only person who actually emailed and said something was wrong here. So anyway, it's really kind of interesting. And again, the goal of that was really for you to understand that the whole vulnerability thing is pretty big. It's like, you have to then get into that whole certificate thing and that whole sort of understanding the trust and talking about the client as well, okay? Because a lot of this only can be controlled on the client. Again, Postgres has the ability to do that, but the default, even in Postgres, is this. So the default for clients, unless you specify your SSL mode in your connection string, is going to be prefer, which we've been pretty horrified by, but we felt that there's been arguments that if we went, this is the default, we would break so many installs that they would just turn SSL off, which would probably make it even worse, right? So we've had it for years like this. It prefers the default. It's disappointing. It's disappointing that nobody calls you to ask about the certificates being changed. Welcome to the security, the world of security challenges, I guess, would be our case. But again, one of the goals of this talk was to kind of explain that whole vulnerability and that whole area of openness. Any questions about that section? So that was kind of I wanted to get that across. I think it's, and again, I try to do it visually so you can kind of see exactly what the vulnerabilities are. And again, Postgres is not unique in this area. Pretty much any software that wants to be secure across the network it doesn't trust is going to have these issues. Okay, browsers handle a little differently, database handle a little differently, SSH handles a little differently. So let's round it out. Let's talk about an area that's a little more concrete, and that's sort of data encryption, which is obviously also a security issue. This happens to be an Enigma machine from World War II. Always a good image there. One of the aspects of encryption is disk volume encryption. So this is actually independent of the database, where you actually encrypt an entire volume. And the reason you do that is to prevent the theft of the device. So if the device is stolen, not so much access is stolen, but is breached, but actually the physical device is stolen, it's encrypted, so therefore nobody can do anything with it. And there's some reasonable uses for that. I remember when I was in my in the 1990s, when I was in my 90s now, in the 1990s when I used to work at law firms, I used to be in computer rooms a lot, server rooms, and I remember there was a box in the corner of the server room, a bunch of tapes, and I'm like, Herb, why is there a box of tapes in the server room? Like it just doesn't look good. It's kind of, it's just like, why is it here? He's like, well, he said, if somebody picks up a tape, puts it in their pocket and walks out of the building, they just taken all our data. I'm like, okay, that's a good reason it's here, right? So the point is that not only do you have to encrypt your data, your storage volumes, but you have to encrypt your backups too. Or if you don't encrypt them, you've got to make sure they're safe. So for example, at my house, obviously the servers in the house, there's a fire safe, and then there's a third copy which is in a bank, safe deposit box. So all three locations are relatively secure. In terms of, but again, if somebody was to steal the drive while it's being transferred to the bank or something, right? You have that issue. And there's something to think about. Another issue that is gotten very popular is the idea of encrypting just parts of your data. So instead of encrypting the whole volume or the whole database, we only want to encrypt a part of it. And this is a little tighter because the problem with whole volume encryption is usually once the volume is attached, it's kind of open, right? I understand you can kind of lock it down a little bit, but by encrypting just specific pieces of data, you can actually push the encryption away from the server, and this is where it gets kind of interesting. So here's an example of the use of a utility called PG Crypto, which comes with Postgres, which effectively allows you to encrypt a specific column, in this case, a credit card number. You're encrypting a specific column. You can see the name and the ID are not encrypted, okay? But we've encrypted that, and this gives us a bunch of options. For example, once we encrypt that credit card column, we have to decrypt it somehow. And the question is then, where do we put the decryption key, or where do we put the encryption key, right? Depending on, it may be a symmetric key, it may be an asymmetric key, right? Whether we use public key encryption or not. So in this case, we end up, this is one example where we actually encrypt the data, but the key is actually on the database server itself. So it might be on the server, it might be on a dongle, we might have to unlock it when we boot the server, but effectively it's on the server while the server's running, whichever one you want, okay? Sometimes having the key sort of encrypted on the server, again, if you boot the server, if you don't have the key, you can't read the key, and therefore you can't read any of the encrypted data on there. Unfortunately, once the key has been decrypted, then pretty much everything's off, right? That's kind of not great, but again, operationally, that might be the best you can do. Another option is to put a cryptographic server between the client and the database. So usually this cryptographic server is some kind of lock cabinet, and therefore, if somebody takes the database server, they really can't decrypt any of it because the key's not there. If somebody takes the client, they can't do anything with it because the key's not there. Okay, you're effectively sort of creating a pass-through where the key exists, and you're doing decryption at that level. That's a pretty complicated option because obviously you have to sort of do that surgically. A more common area is actually to put the key on the client. This is interesting because now the database server only has the encrypted data. Okay, so one option would be to send, this is kind of one option, is to actually have the client send both the data and the key, or actually send the query with the key to the server. The server gets the key from the client, decrypts it, and sends the data back as decrypted. Maybe that's not a great option. It is an option. A more common option is for the client to ask for the data to come back encrypted, and then for the client to decrypt it. Again, now the server never sees the decrypted data, okay? And the client actually gets the decryption. The problem here, unfortunately, is that the key is only going to decrypt something on that client. So, for example, if I take some data and I store it, and I go to a different client, and that client has a different key, then I can't see any of the data I did on the. So you see what I'm saying? And now you have to manage those keys and make sure you have the right key that goes with the data that you encrypted, because you're not centrally storing it anymore. Now every client has a key. They may all have the same keys, in which case it would work just fine. But of course, then if somebody steals one of the clients, then all the clients are compromised, and all the data that's stored in the database is compromised. So you have to you now have to, not only do you have to issue new keys, but you have to re-encrypt all the data on the database, because now you have an invalid key, you have a stolen key. A more common case, a little more practical, is to have some kind of hardware token where you can stick the key from a USB or something into the key card. There's even some very special key cards that have this, not necessarily USB, but they're like credit card kind of looking things. I've seen some pictures. You see this a lot of government where they'll put it in the computer, and again, they'll take the key with them, and therefore now they can go to a different client, put the same key in, and get the same data. But without that key, really nobody can see it. Now, there's some more sophistication to this. For example, and I'm not going to get into this, but normally you would not use a key directly to encrypt it. You would probably use the key to unlock a key. So you can have multiple people who can unlock the same key. So if one key gets stolen, you still have a way of getting to the key to unlock all the data. There's a whole bunch of sort of chain of command. You can require two people to unlock a key. There's a whole bunch of sophistication you could do in terms of key management, particularly with public key encryption, which allows you to sort of have like a bundle of keys, and then you sign the bundle, and then you have certain people who can access it. Again, that's way beyond where I wanted to go, but you get the idea here that where that key actually gets placed and how that encryption happens is actually pretty key. So that is the end of my slides in terms of what I wanted to talk about. I am ready to take any questions that people have, things that I weren't clear, or things about this issue. It's been a more quiet audience than I expected, but maybe I'm super clear today and everything's going well. I don't know. Yes, sir. So the question is, if you're using hardware encryption on the drive, and you pull that drive out and you take it to another machine, would you be able to unlock the drive? Right. So there's two ways. There's two capabilities. One is that the encryption is done at the software level, so at the operating system level. This is typically Linux or Solaris or any of the FreeBSD, any of the operating systems have an encryption option, so that instead of storing the data raw, it will store it encrypted. And typically in those environments, you'll be prompted when you boot the operating system and you try and mount that drive, you'll get a prompt, and it'll say, you know, give me the password. And the password typically is not the key. The password is typically the password to unlock the key. Okay, so you can change the password, you can have multiple passwords for different people, but they're all unlocking the same key, and that key is then used to encrypt the drive at the software level. So if you do that, then you can take the drive out, you can take it to another server. As long as you have the same software installed, and as long as the same software installed, you're fine. But the problem is that that key that you were typing in has to also exist on that other server. So typically what you will do is, even though you're unlocking that key with a password, you're going to store that key file somewhere else, so that if that server completely melts down, we have that key file somewhere else. We're going to take that key file, we're going to put it on the new machine, same software, type the password in, boom, we can get to the data. If you're doing it at the hardware level, then as that drive boots, it will actually prompt at the BIOS level for the password. My laptop, for example, doesn't encrypt the data, but effectively it's the same as encryption, because every time I start the laptop, I have to type the password in. And it happens at the BIOS level, so I can never actually boot anything until I type that password. And then that password unlocks the boot. Now, there's a whole bunch of things you can do. You can actually, like, people will try and take the drive logic board off the drive and put a different logic board on, but the password is actually not stored on the logic board. It's actually stored on a specific sector on the drive, on the magnetic drive. So you can't chase the logic board. The password's still there. You could probably try modifying the BIOS of the drive and put new firmware in and maybe get around it. But every drive manufacturer does it completely differently, and there's probably a whole bunch of checksum code in there. So, like, effectively that drive without the password. But the beauty of that system is that the drive can go somewhere else and it works fine, because it's the drive itself that has the firmware and the password. So the same thing with Android devices. You have an option on Android devices to encrypt this drive, encrypt the storage. I noticed it's gotten even more popular. And effectively, when you boot it at boot time, it will ask you for that. And then every access to that then will encrypt and decrypt the drive. So in the Android case, not only will you have a password to unlock the data, but the data itself, even if you were to pull it off of the chip, would all be encrypted. Whereas my method, it really just it doesn't work that way. So it's quite a bit of interesting. It's really a question of where your vulnerabilities are. Is it going to be device theft? Is it going to be theft while the device is running? Right? You only need to encrypt certain things. Are you happy if somebody takes the server and walks out with it? A lot of people think, well, if they have to take the server, they're going to unplug it, and once they unplug it, everything's going to get erased. All your RAM's going to get erased. But you know, like, there's this like hibernate button, and you hibernate your server, and then you walk away with it, and you just power it up again. Everything's still there, right? So the idea that people can steal stuff is, you know, they'll find a way. They will find a way a lot of times, and so you have to see what your vulnerabilities are and what you're willing to put up with. Yeah. Yes, sir. So, so the question is, is there any case where you use like a one-time pad? I have not seen that implemented. I've implemented that myself on my own server. But effectively, a one-time pad would be you pre-generate a whole list of passwords and then use one at a time. Postgres does not support that capability, although it wouldn't be very hard to create, because effectively it's a database, so like you can put them in somewhere. But I have not seen that. I've seen one-time pads used a lot less now. I think because public key, private keys become so popular, you just don't see it as much. But certainly in military, you still see it. I still use it. I have a little piece of paper with a whole list of passwords on it. Because sometimes if I walk up to a terminal, I don't really know like a public terminal. I don't trust anything on that. I don't even trust SSH. Well, I shouldn't, right? Because who knows what that thing's doing. One thing I should point out is these slides are available right here. That is my website. And there are probably 30 presentations there, all PDFs. So feel free to kind of look around there. I should have mentioned that at the beginning. I always forget. But yeah, that URL there has this presentation and, again, a whole lot more. Thank you.
Citrix Zen Server gives you everything you need to integrate, manage, and automate a virtual data center, all on an enterprise-class, cloud-proven virtual platform, and at a third of the cost of other solutions. But why even bother with virtualizing your server infrastructure in the first place? Well, let's say you have a traditional one server to one application architecture, but you're running out of resources and performance is suffering. Once you order new server hardware, you'll wait for delivery, configure it, install your business application, stage and test the server, and finally, add it to your production farm. If you've been through this process before, you know it can take weeks or even months. You also know it's a manually intensive process that will burden your team every time you outgrow your current setup. With a virtual server solution, you could accomplish all of that in less than half a day. Server virtualization software separates the OS and application from the underlying server hardware. And with multiple virtual machines on a single server, you can use each of them to run different OSs and applications. This makes it possible to move your virtual machines from one piece of hardware to another whenever you want, to maximize utilization, simplify maintenance, or recover from a hardware failure, and without slowing down your applications or users. Clearly, server virtualization provides big benefits, and Citrix Zen Server provides even more. Since it's built on an open platform, Zen Server plays well with your existing hardware, storage systems, and IT management software, as well as with the industry's leading cloud service providers. Best of all, you can get started by downloading a fully functional, production-ready version of Zen Server for free. After a 10-minute installation process, you'll see how easy it is to start virtualizing your workloads and automating your IT management processes. And when you're ready for a richer set of management tools, just upgrade to one of the premium editions of Zen Server. So whether you're interested in virtualizing servers for the first time, expanding your server virtualization footprint, or moving server workloads to the cloud, download and install Zen Server today and see how it can help you simplify your IT environment. Citrix Zen Server. Do more. Don't spend more.
customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.